Today's class is on formwork, right? We will have two sessions today. Number one is formwork classes, and then another one on how you feel about this course. What are your appreciation and clarification required questions, whatever the related to any matter related to this module, you can ask and I reply immediately. If I can't reply immediately, I will post you later on. We'll do that in the Padlet later on. Let's start with this class today. Meanwhile, I will also give you the briefing on in between I plan to give you briefing on coursework, another coursework. Okay, this module will have 5 course learning outcome. We have completed 2 of them. Now we are going to do the third one. Classify the temporary structure such as formwork and scaffolding. It will be a separate outcome that is expected out of this module, right? In olden days, it's content based. How much content you learn. Nowadays, it's very specific to the outcome of each class. If not each class, at least chapters. What you learn with respect to that particular chapter. So today's class, I try to complete by today, or the scaffolding will follow by next class, because each one is having about 70, 50, 80 slides. So I may take 1 or 2 classes for covering this CLO. Classify the temporary structures such as formwork and scaffolding. Formwork is the one which is forming the structure. Okay, forming the structure. One moment. Objectives of this class will be learning about construction, deep foundation installation continue. I will do this by reviewing on your quizzes last class, right? How this is done. And then formwork, the types of formwork, construction of formwork, advantages and disadvantages of formwork, requirement of good formwork, and quizzes. Quizzes, if we have time, we do today. Otherwise, we will finish with Padlet. Can you all hear me?
Yes, ma'am.
Yes.
Yes.
Okay. Let's do a quick review on last class quizzes. We had 3 people on top. Number 1 is Fanny Zhuan at the first place. Second one, Benson Lee. Third one, Lim. Okay. Give them a big appreciation by joining your hands. Okay. I can't see you. Thank you. Then next, first 10 places in our class are on the topic of deep foundations. The day we taught on deep foundations, right? The results are Fanny Zhuan, Vincent Lim, Ton Park. Sorry, I don't. Please give your name. Whenever you participate in any, give your name so that we know each other. Mohammad Zain, Mohammad Sazad, Badr, Chin, Tang Yao, Vincent, Calvin Tan. These are the people, the forefront. So try to beat. Actually, funny it was during the session he was in 3rd or 4th. Suddenly jumped to 1st place. Appreciate. Okay, good. Let's proceed with the class today. Formworks, right? Sometimes I use the board. I don't know whether you can see the board clearly. You see here. You can see the board, right? When I draw, you can see, right? You can see. Can you see the board clearly when I draw? Can you answer me? You can see the board clearly or not?
We can see it clearly here.
Huh? You can see it.
But my problem here is I should see either one, the one you write in the whiteboard or not the slide you share.
Oh, like that. Okay. Go ahead with this using my iPad. Okay, I try to manage with this today. Then we will see how effectively we can use this gets. Okay, start with formwork. You are seeing here all the. Well, let me check the pointer. Different types of structures here, right? You are seeing different types of structures. Formwork are the containment structure, or what you call it is going to form the structure that you need. What are structures you'll be doing? The elemental structures. It may be beam, column, slab, footing, right? These are the elements you will be constructing. So for constructing these elements of its required size and shape, you need to use these temporary structures. Don't confuse between formwork and scaffolding. They are two different. Formwork are the formwork which will help you to hold the structure during its construction. Okay. Once it is set, after construction, concrete needs, if you are using, most probably they will be using concrete. Olden days they use brick and other stone masonry type. Most commonly they use for concrete. So once it is set, the structure is completed, required strength is achieved, they will remove the formwork. That's the purpose of using formwork. It is to hold your required structures in construction. Here you are seeing a beam, a long beam sitting on columns. See, this is a formwork constructed for with the side support. You will learn all these things part by part later on in the slides. For now, just understand this is beam supported by the columns. So they are going to construct a beam and a column, and the scaffoldings are shown here. And this is wood, and this one is steel. Okay, I wanted a review on the previous one. Okay, we will do it at the end of the class, not urgent now. This one is on steel, right? In most of the chapters, it is important that you learn how they are differentiated, because one of the outcome is to say how you are able to differentiate different types of structures based on their material, based on their conditions. Maybe sometimes it is classified based on the site condition. Say for example, the piles are divided into based on the conditions of the site and also by material. It may be steel pile. When I ask classify the piles, you should know whether on based on both or either one. So you can classify by material or by site condition. Shallow or deep foundation. Within shallow, you have different types of foundations, right? Raft, spread footing, many other. So you can classify based on the site condition as well as material. Similarly, here also you can classify by material. This wood, this steel. Steel formworks are used for, this may be wall, you see, continuous. So it's going, they are going to construct a wall. That's why it's continuous, supporting continuously. And then here you are seeing the slab. They want to construct a slab. That's why you are seeing the scaffolding supporting the formwork or the structure, right? The structure or the bottom slab, bottom plate, which is used for pouring concrete for the construction of slab. This is the slab, and these are constructed columns already. And then they go for this construction of this slab. The slab is supported by these scaffoldings. This is the scaffold, mean formwork for slab. And this one is a staircase. Staircase is also slab, right? Considered to be a slab. Construction may be a beam, but analysis purpose you do the cut section, take it as a beam, but in design you should construct it as a slab. So the slab is like this. Okay, and you are saying scaffolding, sorry, the formwork used for construction of the staircase and the steps also made out of concrete. That's why they form the structure or do the formwork structure for both the slab, staircase slab, as well as the steps. Okay, and then these are the slabs, the floor also using um, concrete. So they will do the reinforcement. Now these are called reinforcement. Later you will do, you engineers will be designing these members, right? The reinforcements, like what is the size of the iron boards, what is the spacing, what is the main bar size, what is the secondary board size, what is the covering size, what is the spacing of the covering, what is this is the beam, and this beam, and this is going to be slab. So it's a continuous slab or separate. All these things you will be designing in due course, maybe in second or third year. This is first year module. You'll be doing it in second or third year. Start with analysis and proceed with your designs. Okay, any question? So these are the pictures on. You can stop me anytime. Either you raise your hand or just stop me and ask question if there's any. Okay, let's come to the section of parts of a scaffolding. I may ask in your assignment or any of the questions giving the structure, mark the parts. Okay, just remember these words in English. It's common in everywhere. Nowadays it's global, right? Whatever the invention, whatever the material, whatever the findings, all global. The one invented in Dubai, India is using, Malaysia is using, Singapore is using. The one invented in Australia, Netherlands is using, right? Austria is using. So it is global. So there is no regional word used. You can use this as a common one. All places they are called as base school Jack, right? This one is Jack. This structure is showing. What is this? Okay, this is the formwork arrangement, formwork structure used for construction of maybe a slab here. They're going to construct a slab and a beam and column later on, right? Let's understand the parts of the formwork. Start with the bottommost, which is on the ground. These are all temporary structures. No need of foundation. Proper permanent foundation is required, not required. So just hold it on the ground. Just put it on the ground, supported by this plate, screw jack base, strong enough to hold the structure above, and then a tower frame, right? A tower, and then this is connected by, and different columns are connected by these bracings, diagonal bracings, right? Because they're running diagonally, so they call this as diagonal bracings. At the end or in between the column and the slab or beam, the ends are called beam, the middle part is called slab. So the beam and the column is connected by what is called screw jack. Okay, this is base jack, this is just screw jack. And then coming here on top of the beam you have runners, right? There's like this type of horizontal runners perpendicular to the beam. It's called scantling of size, 80 by 80 they are given already. This is the planking or the things that is going to hold the slab. On top of it, they either they may construct it as a steel frame or uh, a concrete one. So plank, a wooden plank that is used for holding the slab. This is plank and this is beam. Okay, this is beam, this is slab going to be constructed. That's all. Connecting pins. See the connecting. There are interesting videos. At the end of the, I cannot run all the videos within this 1.5 hours. I request you to go through the videos posted at the end of these slides. Last slide I always have what are all the videos I'm asking you to go through. In that you can see all these connectivities, all types of connection screws, all handy many things I put there. Although it is not under the scope of the syllabus, you have to know. Then only you can troubleshoot. You know better than. Better you can be successful as an engineer, site engineer, supervisor, right? Sometimes manager, become manager. You should know how to fix it immediately, right? Immediate, if not a long solution. You should able to fix it immediately. So these are the types of connectivities available. What if there is a breakage? What if there is a failure of the system? Immediately you have to fix it. And there are some videos you can go through later on. For now, I just go ahead with the theory first. These types also. Last time you see this as a pin, right? The ring pin, connecting pin. Now this one will be like this. I show one video in each class. Okay, the rest you please go through yourself. This is for the column mold, right? This is they are going to construct a square column. A square seems to be square column, almost similar. This is the mold used for constructing a column. That's why it's very high. It's a box type column. And these planks are supported by how this column is made by different planks, right? The small size planks put together and they are joined together by these angles, locking pin. And these angles, these plates are fixed by or connected by these locking pins at the corners. At the corners of the square, the locking pins will connect and hold the column. So at different intervals, the stage by stage they build it, connect it by using these flanges and the pins. And last one, the bottommost plate is called as mud seal, connected to the, like the last one, you have a jack plate at the bottommost, right? Jack plate. You have here the mud seal, just fixed onto the ground on soil, and then nailed, maybe nail or just fixed firm to the ground. This one another type of holding, another type of fixing. You have this is a wall. It might here the size thickness is what may be the, can you imagine what may be the thickness of the walls that you are having? Maybe you take your home houses, what's the minimum to maximum size of a wall? Can you tell me size of the wall? Anybody? Critically, you must think critically, not just listening.
125 to 150.
1502.
125 to 150.
Um, you're saying partition, only partition. Okay. Partially correct. Partition walls, the walls within the rooms within the house may be running about 100, not 100, 200, 150 to 200, right? The main wall, which is constructed outer, will range from minimum 1 foot. The strong wall, right? The outside may be running from 1 foot to 3/4 of the 15. What is called? Is that 150, mean more than that, 200 or 250, even 300 will be there. Okay, go up to 300. The main walls, partition walls are just half or 3/4 of the main walls, depending on the loading condition. Okay. Uh, so it ranges from 200 to 300, you can say, right? There's a size of the wall and they're using here. So you ensure that you maintain so whenever you're using the scaffold beneath the formwork, care should be taken that you ensure you maintain correct size, you fix it firmly, right? You fix it firmly, otherwise the continuity loss, especially construction of walls like this, you should really keep it keep it there should not be any joints, right? Joints or breakages, gaps in the construction. The formwork should be constructed such a way that the size is maintained, continuity is maintained, no gaps, and material is filled properly. Right. Let us see here. This is another type of pin, right? Fixing clamp. They use it as a clamp, and they have a common padlock, like padlock. They just a common pad, and then a clamp is used to lock it. All these things are connected by this clamp, fixing clamp. Right. Then is a mold or box into which wet concrete can be poured and compacted so that it will flow and finally set to the inner profile of the box or mold. See here, one of the structure. This is foundation because you're seeing below the ground. This is ground surface, maybe used for the pile, maybe pile construction under the ground. They use the formwork into the mold. After making a formwork or the mold box, you pour the concrete inside, wait until it settle down. After curing time, say for example, depends on the concrete grade, 24 days. Nowadays you have start from 3 days, 3 days, even within 3 days, depending on the structure and depending on the type of concrete, the grade, they will allow the timing for curing, 3 days to 24 days. Which type of grade is it, and the proportion 1:2:4 or 2:4:8, something like that, depending on the material and the elements, the concrete grade will vary, right? Is a mold or box, so that is it, and then so that it will flow and finally set it to the inner profile of the box or mold. So they pour the concrete inside such a way that they fill, occupy the whole end to end of the boxes on all directions, and this is the code you can refer through if you have any doubt. And mostly I borrow from international codes, because you're all international students, you better follow this one. If not, your country will have your own code, right? You can refer from Department of Works or Ministry of Works, or in Ministry of what it depends on your country's ministry. Wherever you are posted, you follow their codes and manuals for your construction. This is International CIS 23 2008 18 is a recent one. Safe use of flash work and formwork in construction. Construction industry standards. CIS is referring to construction industry standards, and the website also given here. Okay, for more reading you can go through. They have given all the criteria and the norms and the standards for using these types of walls or the formwork. Purpose of formworks. Purpose to contain, it is to contain freshly placed and compacted concrete until it has gained enough strength to be self-supporting, right? Only if it is settled, it can self-support. Then no point you are keeping this temporary structure there. You can remove the temporary structure. You have a finished final product of your beam or column or slab. So temporary structures to support the fresh concrete until it is strong enough to support itself or reach the strength of the concrete and to the applied load. That's important. The purpose of making your concrete beams or columns is to support the load, overcoming load, right? Support the overcoming load. It may be static load or dynamic load or any type, right? Starting from wind load, earthquake load, self weight, and all the live loads coming over the building has to be supported by these types of structures. So depending on the type of loading, depending on the type of location, it will be changing. So you ensure that you achieve this strength, right? You achieve this strength by constructing the particular member, and the purpose of bearing load is ensured or achieved. To produce a concrete member of a required shape and size, we use formwork to produce a concrete member of required shape and size. If no form, no definite boxes or mold, it will go in a different or irregular shape and size will be achieved. For that, you should use proper formwork for achieving the size and the shape to produce the desired finish to the concrete. Not only the size and shape, desired finish, a smooth surface, right, a straight surface, a uniform surface for better view, a better architectural view, and then also for other works like finishes. When you apply finishes, you won't incur more of the finishes. It will be good enough if you have uniform surface made out of this concrete or by using these formworks. Maybe desirable, oh sorry, maybe described as described as a mold or box. Concrete formwork is described as concrete formwork is used as a temporary structure to support the fresh concrete until it is strong enough to support itself and the applied loads. That is just now I explained. You have to wait until it settles and then only you can remove your boxes, temporary boxes. Formwork requirement is also most important for your learning. What are the requirements of a formwork, right? You cannot just like that build it or like a layman work. That should be proper. It's mainly because nowadays you are getting many types of materials, right? Whenever you go for new material, the modern materials, make sure all these requirements are fulfilled. There are so many. Actually, I collected from 3-4 sources and put down this information for you as a summary of all, a comprehensive numbers for you. They are 7 only. Rigid, tight joints, shrinkage and swellings should be minimum. Simplicity, standard size, form finish, economy. Right? In future, one of you, like our friend Fanit, he's going to do research on our new innovative material for formwork. Then make sure that all these 7 conditions are fulfilled. The material that you found should be having tight joints, economic, right? Economic, standardized size. It should have standard size as a because size also matters, right? Depending on the loading, the sizes vary, and the respective strength will follow, strength of the formwork. If it is not strong enough to hold the concrete, collapse, right? The whole structure is collapse. So make sure all these conditions are fulfilled. Rigid to prevent bulging of moment. Yeah.
Yes, we are. The slide is still stuck in the slide number 12. We didn't move to slide 13.
Okay, I share again. I didn't notice. Okay, by the way, ask one more question. Do you have these slides already? I have been already posted to you, right?
No, not really.
Last class? What about last class?
He posted the deep foundation one.
Oh, this one not yet, huh? Okay, okay. I will post it after the class. Let me finish the class and post for you, okay? Better I post one class ahead. Huh? I mean, like last class means, next class for slides I will post this week. It's better you have a read and come, okay? I thought he posted all the slides to you. I didn't check, sorry. Next, after this scaffolding, so I'll post formwork and scaffolding by today, right? Where we are here, you can see, right? Yeah. to prevent bulging of movement or movement from pouring wet concrete. So it should be rigid, strong enough to withstand the load of, what are the load? People moving, right? Sometimes if it is first floor, second floor, the people are moving, should able to bear the weight of the people moving, coming and pouring the concrete. And then as the height goes, right, the weight will be changing. All these things should be managed by strong enough to hold by this formwork that you design. Tight joints to prevent wet concrete from leaking and strong, right? Joints and joints, there are chances of leaking. If you have tight joints and smooth finishing, you can avoid such leakages and wastage of concrete. Shrinkage and swelling should be minimum, right? Yeah. uh, Material wise, the material due to free what dry and hot season, dry and wet season, there is a chance of freeze and thaw. You should able to decide what type of material it is, whether it can withstand this shrinkage and swelling with respect to the climate. And then simplicity, easy erection and dismantling. Yeah, should not be heavier. Formwork itself is heavier, means you will be employing too many cranes and manpower. Workmanship will be very tight and expensive if it is not simple. Bond breaking agents such as grease is typically applied to the form faces to prevent concrete sticking. Yeah, you should have simple and easy, lightweight to handle. Lightweight, at the same time rigid. Ensure that it's rigid and also handleable, manageable to replace, bring to the site, and from the trolley or truck have to bring to the site or the place where it is to be constructed. So it is easily handleable, manageable at the site, and also uh, for preventing a termite. And termite, they sometimes use termite, some kind of insulating materials will be applied, and your material should be able to accept the material, the kind of termite or otherwise what do you call, the insulation material that they are putting should mean applying should be uh, all right, should be all right or acceptable, or not having any other side effects, right? Due to the material effect, there shouldn't be any side effect between the material formwork and the concrete. So care should be taken for all these things. Standardized sizes, allowing reuse. Yeah, yeah. Formwork that is constructed, contractor is supplying, means he has to use it at the other side, remove and use it at the other side. At least 2-3 years you should run. It's not that every side is using it and broken or not reusable, right? Should be reusable at least for 3 to 5 years, maximum go for 5 years. If it is steel, you can use until 5 years. Nowadays PV polymer modular construction, right? They just bring it the side, the block itself and constructing, so no use, no need of formworks. Or otherwise the what polymers, mostly they go for polymers, which is coming for long run reusable. And then form finish, to achieve desired texture and appearance of finished product. Form finish, so the ultimate size and the shape should be a smooth one, not undulation. It should not have an undulation of the inner surface that will yield another undulation on the concrete that you are producing. So you should have a smooth and uniform finish inside the formwork, so that you will have the final product clear and uniform. Economy, simple, affordable, easily handled and standardized. Affordable by the people to purchase and use it. Otherwise, it will be costing more for your project. General formwork requirement should be strong enough to support the load of wet concrete, which is generally considered to be approximately 2.4 or 2400, right? 2400 kilogram per meter cube unit weight. They are giving unit weight per unit meter cube. It will be costing about, weighing about. Actually, they should not give in this weighing. It is considered to be approximately 2400 or 2400 kilogram per meter cube, right? So imagine per meter cube, this is the kg. Then how much kg your formwork should have, how much kg per meter cube it should bear. You must plan accordingly. Then formwork should act as a temporary structure that supports its own weight freshly placed concrete, construction live load like material they put the materials and bring the material spans, some kind of the I mean the consolidator, right, the mortar that they use for consolidation, the leveling, the removing, pouring, right, all this may weight of the materials are the instruments used, the equipments used, people moving, and then logistics, right, they may be transporting. So all these things, the moving load should be accounted when you design or when you construct a temporary structure. All these types of loading will be borne by the temporary structure. So care should be taken in designing with respect to all these requirements. Must have rigid, tight joints, and so on. Okay. Any question? Okay. General form of requirement. It must have crowd tight joints. Crowd tight joints. Crowd leakage can cause honeycombing, right, of the surface or produce fins which have to be removed. The making good of
Excuse me, ma'am.
yes, yes.
The slide is on formwork requirement.
Yeah, okay, now moving. Okay, good. Oh, I did this one just now. Unit wide, right? This one you heard, right? This slide. Okay. I repeat once
Yes.
again. I repeat once again quickly. Unit weight of the concrete you should know, right? 2400 kg per meter cube. Having understood the weight of the concrete that you're going to pour, in addition to that, you have other weights that is going to come over the temporary structures that you build for making your beams or columns or your structure, which are its own weight, like concrete weight, fresh, I mean its own weight means the material weight, formwork weight, freshly placed concrete weight of this unit weight, and then construction live loads like material, human, logistic. All these types of loading should be accounted, added, and tally with the weight or strength of this temporary structure. Then only you can recommend for construction. Okay, general formwork requirement. It must have crout tight joints. What is crout? Crouting is another process itself. I will explain this. Let me read this. The making good of defective concrete surface is both time consuming and costly. Crout leakage can be prevented by using sheet materials and sealing the joints with flexible formed polyurethane stripe or by using a special self-adhesive tapes. Okay, in first place that if you fulfill this requirement there is no problem, right? The form should be having smooth finish, uniform finish, then there is no issue of your grouting, need of grouting or any leakage, right? You can avoid leakage by having smooth finish, smooth joints, right? I mean perfect joints. You can avoid leakage, you can avoid any difference in size and so on. Same goes here. What if your um, you have the joints problem, it is not tight, it is not tight. Crowd tight means the crowding is operation to remove all the gaps, to remove all the what do you call air packets, uh, what the gaps, mainly the gaps of the joints, joints in the at the joints, gaps of the joints. So crowd leakage can cause honeycombing. If there is any gap or holes at the joints, it will form honeycombing, a type of honeycomb. You know how the honeycomb, right? Honeycomb, you have you seen honeycomb? Small holes, right? Small type of holes, which is ugly, and that will yield a poor strength of concrete, right? There is a chance that the structure will fail through this type of honeycomb portions in the concrete. So you have to avoid such type of honeycombing caused by loose joints. Okay, loose joints. You should have tight joints and avoid honeycombing, and then it will start fencing, it will start spreading, and that has to be removed, right? Crowd leakage can be prevented by using sheet materials. Yeah, how do you remove this type of in case it is unavoidable, it has caused you should identify. Number one, you should identify, right? If at all you cannot make a good finish, perfect joints, check the joints, right? Check the joints. Once you pour the concrete, you found there is a leakage at the crowds at the joints, you find the gaps, immediately you seal it, immediately patch up with the concrete, or otherwise you can go for adhesives like this adhesive tapes. Adhesive tapes, durable tapes. There are many in markets nowadays. You can buy and seal it immediately. In this case, the engineers at site, the supervisor at site should be taken care for avoiding these types of problems later on, right? General formwork requirement. It must not be able to deflect under load, which would include the loading of wet concrete. Just now we studied, you should be able to capable of withstanding all types of loading coming in, right? You should not deflect, change, move, dislocate, and so on when you pour concrete. It must be accurately set out, right? Accurately set out. Size should be correct. Concrete being a very soft when placed, it will take up the shape of the formwork, right? That's the purpose of formwork. So you should design, if you are designing for, if you are constructing a 4 by 4 beam, your formwork should be 4 by 4, not even 1 mm differing. It should be exactly 4 by 4, right? So when you pour concrete, you will get 4 by 4 beam accurately set up to the size you design. Concrete being a very soft, so they take up the form, which must be therefore be of more of the correct shape, size, and in right position. Because it is going to take the shape of the beam, right? Ultimate product of the beam or column. You should mind shape, size, and positioning of the form work. The example one I want to show. Okay, you can see. See here, honeycomb. It's spinning around, spinning around like this, like this. Slowly it will eat away all the material, eat away all the material, end up with failure of the structure itself. So to avoid this, you should patch up with the concrete or seal it with the adhesives, any suitable adhesives, strong adhesives. Applying the procedure in the tape, in the box itself is written the procedure. What is the primer, then what is the next you can apply. So you need to find out and apply accordingly. I myself don't know there's a video. There's a video based on this former. You please listen to this one. One moment, I will share it. It's a nice project in China. That's why I brought it here. You can go through. You can see, right? One moment. You can watch later, but this is repeating somewhere. Thanks for watching the video. Can you tell me what are things you saw in the video? Hmm? What are things you saw? Are you hearing me? What are things you saw in the video? One by one, quickly. Hello?
They poured some mold oil.
Installing formwork.
Aluminium formwork.
Very good. They use aluminium. They use aluminium. They pour concrete, and there's another answer. Quick, one by one. Technically,
Is
answer
that they
technically. The
poured
things that is
some
wrong.
Dismantle the formwork.
mold.
Dismantle the formwork after setting. Okay, by mechanical means like just unscrew it or break it, right? Break it or unscrew it, break the pin or unscrew it. They open it. Then any other things you saw in the video? Important thing.
They cover oil on the formwork.
Apply the oil purposely so that there is clear removal. And when removing, it will be easy to remove. Oh, very good. Next, chemical, it's not oil, chemical. And then any other? Any other? Quickly, 2 more minutes. That's all. So you have
Uh,
seen. Yeah.
Is it a
use
software?
of oh,
You switch on your camera. Why every time you ask me to say this? All of you switch on your camera, right? Make it interactive so that you remember. It's lifelong. If you say in the class, it's lifelong. I'm telling you. Uh, you are familiarized with the terms and methods you are learning. That's why it has to be interactive. It's more important because we are attending online. We are not in person, right? You should involve all physical methods of learning as much as possible through online by talking, by seeing, by listening, by asking. Uh, I put purposely the camera on so that you know the expression, right? You should know, you should feel it, right? When I say this is strong, this is light. Tell me, uh, something, leave it. Okay, tell me please. Switch on your camera if you can, right? I admit all of you switch on your camera, but mic, whenever you talk, you on and put off, okay? In my class, all of you can switch on your camera. Tell me, where we are. Okay, let me proceed with the class. Later we'll discuss. At the end of the class, I will discuss the last class quiz. When there are some poor performance, you can correct yourself. Where is it? Where is it? Where is it? It's already shared. I do it once again. Okay, right? I got it. Right. Now, types of material models in this company, LS Dyna, right? Metals, plastics, the formworks, petals, plastics, glass, foams, fabrics, elastomer, honeycombs. Nobody said there is a somebody one guy filled the gap, right? Fill the joint, the gap, the honeycomb develop. Concrete, soils, concrete and soil, viscous fluid, user-defined materials. Yeah. One moment. I open the file. Any questions so far? No
No,
question.
ma'am.
Okay, one moment. I take the slide. Next slide for you. 9. Now we are going to see the requirements. Requirements of form work. This slide is over. Next is requirements. Based on the requirements, it's all about construction only. You are not going to have any paste. Because you are were delayed. You I don't know, your slides are delayed. All these things I will do it. One moment. 7 point. This is week 7, right? 7.1. Okay, I start from here. Requirements. I can't find the slide. Seven is not coming. One moment. I can't find the slide. I open from the folder. Okay. Formwork design. What are the formwork design requirements? Just now we saw, right? How many points quickly while the slide is loading? What are the requirements of a formwork? Number one should be rigid, isn't it? Next,
Tighter joints.
tight joints. Next,
Simplicity.
simplicity. Next, means handle manageable. Huh?
Standardized
Very
sizes.
good. Standardized size. You said almost.
Economy.
Economy 5. Two more. Two more.
Finish.
Hmm?
Leakage and shrinkage.
Avoid leakage and shrinkage. Last. Hmm.
Standard size.
They're done already. Related to. Okay, you got this. Which one is
The
loaded?
grout joints should be tight.
You can't see the slide. Why the old one is coming always? I don't know. One moment, sir. The old slide is coming. What's happening? Let me move on. Give me a minute. I got it now. Maybe overuse of sharing. Right, we are here. General requirements, mainly it's required for designing and construction of the formworks. Sufficiently rigid to prevent undue deflections and placing of the concrete during placing of the concrete. Sufficient strength is working load and the weight and pressure of the wet concrete, which is an incidental loading and vibrations, because after pouring concrete they use the vibrators to consolidate the concrete, right, settle down the concrete. Set to line and level within the specified tolerance and include the camber and include any camber which may be required. So, a smooth and uniform finish should be there. It should be in line with the formwork and leveled, not undulated. If it is wall, the surface should be leveled, not undulated. Joint should be sufficient. We all done this one, right? Maybe I put it in a detailed way. Size of panel of units should be should permit easy handling, and then erection and striking. Design should permit orderly and simple method of erection and striking. So handleable, manageable, or simple. Arrangements of the panels should be such that they are not trapped. Okay, they are not trapped or leave any joints, any gaps during striking, and it should be possible to strike side from beams without distributing the soffit formwork. Soffit means the bottommost, and the bottommost portion should be clearly finished, clearly closed while striking one by one. Design load on the formwork. In addition to knowing the 7 criteria of requirement of a formwork, you should know what are the types of load coming in, a specific load, so that you can calculate and design it properly. ACS, ACI, American Concrete Institute in the Act, the number, section number 347, to form guide to formwork for concrete states that these are the types of loading one have to consider while designing and constructing a formwork. Dead load, live load, lateral load on formwork. Dead load is the actual weight of the form based on the concrete grade and the mix, fresh concrete. And then live load, weight of the workers, equipments, materials, storages, etc. The one I said before. Lateral load of formwork. Wet concrete is like water, excess lateral pressure, which increases with depth of the form. As you pour, it will try to find out, because a slurry form, right? Liquid, semi-liquid. It will try to find out the ways to fill inside the formwork. So you have to have wet concrete is like water, exerts a lateral pressure which increases with the depth of the form. It is not only static load, that is gravity load, that is applying, it is also lateral load while it is filling and increasing the load onto the walls, towards the walls, right? So it has to support lateral and vertical loads. What is he doing? Already written there. A worker on the project greases the joints, right? It's a formwork. He's greasing the joints so that the removal of formwork after the concreting will be easier. He's greasing the joints between boards to ensure that they are crowd tight. They are crowd tight, okay? Gap tight. Tight lung. Crowd means it's a gap or loose joints like that. So it is crowd tight, okay? It is tight and then it is packed with the concrete later on. Come on, let's classify the formwork based on the material. Let's understand what are the materials, what are the advantage, disadvantage. There are many things when you go to the site, and there are many things you need to consider. Now you are learning the theory, but when you go to the site, all types of ethical, technical, managerial, all types of problems will rise. You have to manage, right? Theory. One moment, sir. And this phone is ringing. One moment, sir. Give me a minute. Okay, sorry for stopping. Okay, materials: wood, metal, and plastic. Okay, wood, metal, and plastic. All types of wood I can consider. Wood may be timber, plywood, right? Plywood, timber, plywood, or otherwise. Here we are using only timber and plywood. Balsa wood, which is very expensive, but wherever it is necessary to carry a heavy weight, you can use balsa wood. But they are all site specific. You can design according to the contractor and the supplies at the site. Mainly they are of timber and plywood. Metals. Metal may be steel, aluminum, right? In the video you saw aluminum, right? All of aluminum, right? Aluminum strong enough to hold the concrete and the whole structure itself. It was a nice video to give the picture of how the formwork is made, how the construction and the dismantling of the formwork was done by that video. Hope you can imagine always those types of concreting and then the construction of using formwork. Whenever I say these things, plastics may be glass reinforced, right? Plastic formwork, any type of plastic or polymer, or sometimes glass reinforced to increase the strength. Okay, come on, cost wise and pictorially you can say, and I saw this photograph in the Google. It was nice to understand how costly they are. Wood, some amount, a bit higher is plywood, and then this, sorry, this one is metal, I think. One moment, plastic. Mm, wood and then plywood, should be plywood. Wood and the plywood. I can't One moment. Metal, plastic. Should be metal. Wood, plywood, and the metals. Metals are expensive and long lasting. At the same time, long lasting. No need to repair. Maintenance is very less. Okay. And then this thing is polymer. All types of polymer based. This is comparison between timber, any type of wood, plywood, and the metals. You can choose based on the monetary the available budget available for the construction, and then decide which type of formwork you can purchase. Sometimes it depends on the decision you make or the supplies you have at the site. Timber formwork. Let's start with one by one. We'll analyze one by one. The advantage, disadvantage, the strength, they are varying, right? Timber formwork. See here the example one, timber. Using timber, they support the structure we're going to construct. Basic standard qualities of a form of timber will be of reasonable price, right? Affordable price. It's wood, right? So affordable price and available, and readily available. Should not be so soft, right? Cannot be soft. Should be easily worked by hand and or machine or nailed easily, right? Workability, working customizing up to your sizes, required size is easier, and should be stiff to avoid deflection, right? The timber that you should chosen is very stiff, have to be very stiff. Choose the right type of timber material. Timber have many classification. Choose the right type of timber. Should be stable when exposed to sun or rain, right? Not low quality timber, high quality timber, so that it is the weather problem, the climate problem is not there. Should reduce defects, like the honeycomb is one of the defects, right? Or like the white patches, after some time, wet and dry, or on I mean keep repeating, it'll cause some white patches on the surface. That should be avoided. Growth of fungal and so on. Not suitable for green timber. Moisture content not less than 20%. So avoid green timber, and then moisture content should be 20%, less than 20%. Okay, 20 up to 20% is bearable, right? More than that is difficult to manage. Your class until 6:30, right? Oh, we passed 1 hour already. So fast. Okay, see here all these types of construction. This is column. Where is it? Concrete, concrete column using timbers, using timber, also using timber. This is column, also column, and this one is the wall. Wall is constructed using timber. Wall is constructed using timber. One moment, sir. Come on, can you answer me? What are the disadvantages? Just quickly imagine. You know what is timber, right? The quality of timber, the material. Hey, you had a material section. Material, Pani. What do you call? Construction material. You studied already, right? You studied construction material. Am I right?
No, miss.
Not yet. Oh, sorry. I should say construction material should go first. I mean, the next PCRC I will recommend. Right. Okay. If not construction material, you know the quality of timber, right? What may be disadvantages against metals and plastics or polymers?
Termites.
Yeah, very good. Insect attack, infection, and then any other? Disadvantages of timber. These are the requirements. Actually, this slide says all the requirements of a timber that you are choosing should be affordable, not so soft, easily workable, strong enough, stable, right? Not very light and fly away, right? When you pour concrete, reduce defects, right? And the timber you are working, right? You are working from the mill, you prepare the wooden planks and play panels, right? In that case, avoid any defects, right? And then not suitable for my green timber. Avoid green timber. Dry wood with handleable, good quality timbers. moisture content should be 20%. All these things are requirement. On the other hand, there are some defects. That's why we have to go for some material, something else, which might be your metal or polymers. Okay, and this is on another. I don't know whether where is the timber, somewhere here. Only for the slab, the slab they are using because because very high height. So they use the steel as a scaffolding, but for the slab they use the wooden planks. It might be the Singapore one. Singapore, what is that? The garden, Bay of Garden. Forgotten the name. Bay of Garden near the airport, Singapore airport. During construction, this photograph is taken during construction. And the next one is the foundation formwork. Okay, see here, timber successfully used for foundation formwork. Number one, this one is a staircase. Timbers are used, right? Staircase, a reasonably good weight, not so heavy, so they can use the wood as a formwork material. And here he's using the corridor, the portico, veranda, a small veranda, we can say veranda or a front yard. Is preparing the front yard for this house with the slab, and these are the timber used to support the slab construction. Okay, with the bracings and side bracings. Advantages: easy handling because of its weight, easy to dismantle. Dismantling, no need of applying very high force. At times it may break even your concrete, isn't it? Your member. So dismantling should be easier whenever you choose a formwork. Damaged parts can be replaced with the new ones because it's affordable price. Very flexible, more economic, easy to handle and formed into required shape. That's most important. The required shape is convenient in formworks. If it is steel, you see how hard it is to customize to your size or change to your size, right? Either cut or adjust, also difficult if it is metal. Maximize or reuse, it has some reasonable number of years, like 2 to 3 years. Easy to fix, insert, right? Because of the nailing, assembling, the forming, mantling, and the mantling, the workmanship is very easier. I mean, relatively easier. The joints can be fixed quickly. At the same time, you should look into disadvantages. These are all important for your lessons, for your exams and so on. Please make note of it. Based on the material or based on the, this is formwork, right? Mostly based on the material, it will be classified and will come in the exams, remember. So disadvantages of timber work, can't be used for long because, right, not very, not strong enough to withstand the loading for long, repeated number of use. That's why it cannot be used for long. Have limited reuse, limited number of, can be used for reuse for five or six times. If the project is going on in a year, 5 or 6 times finish. If that timber is dry, it will absorb moisture from wet concrete, which could weaken the resultant concrete member. See, the consistency of the concrete may change. Consistency means the amount of water that is present in the concrete, and workability and the consistency is related. So they prepare the concrete such a way that the workability is achieved with the correct number, with the sufficient consistency. If the consistency is lost, automatically the strength of the concrete will be lost. Right? So care should be taken that the water or the wet concrete should not become dry because of the absorption effect from the timber surrounding the formwork. Timber with high moisture content, more than 20% moisture content, wet concrete will shrink and cup, leading to open joints and leakage of grout. So it is not only losing the strength, also creating gaps, also creating joints at the concrete. So care should be taken to have extra consistency or extra moisture content in the concrete, so that when it is absorbed, it can still withstand the concrete structure. Not enough strength as compared as steel. That's for sure, right? It's not strong enough or stronger than steel. Excessive shrinkage due to, so it's you have to play a clever role between choosing the material whether the budget is matter or the duration is matter or quality you cannot compromise for any project, but see that whether budget is the matter or the structure, and the structure, which type of structure, that's also important to choose. Excessive shrinkage due to temperature changes. These are the temperature effects due to timber. Leakage through joints and apertures, right? So once this is here, it is wet, right? The absorbed water leave the concrete dry. Automatically, they produce the joints, they produce the gaps, and this is joints or the break or cleavages, kind of cleavages or cracks in the concrete that will affect or damage the concrete, leading to leakages and so on. Easily damaged during fixing and uh, wooden material, right? It's wooden material, so removal and fixing should be carefully done, other chances of breaking. Susceptible for breaking during mantling and dismantling. The pattern of grain, knots, bad flaws will leave imprint to the face of the concrete. Yeah, this is another effect we ourselves had one time when I was supervisor at the site. The strains, and the strains, when you finish with other material, you will really have a hectic problem. What do you call the finishing will have incur more time, more effort, and more materials to complete your structure. So it will leave strains, it will leave bad flaws, the knots, right? Knots, all these things will be due to the timber material. So you have to remove properly within the duration of time, and then address the effects due to these types of uh, knots and the bad flaws onto the concrete that has been made by your timber formworks. So these are the things, disadvantages, and care should be taken during timber formwork. This is the effect: wrapping, swelling, shrinkage, right? Because of wet and dry, wet and dry changes in climate, it will go this type, or otherwise this type. It will bend this type, or like this. Difference in, if this shape is changed, automatically the concrete shape will get changed. There is always a hazard to use these types of a risk not hazard, risk to use these types of materials in making high-rise buildings or long period of construction. Hence, you have to go for metal formwork. Metal formwork. Any questions so far? No question. Okay, I'll leave a break.
So
Yeah, please.
so timber can't be used to construct a high-rise building because it's too heavy.
The number one is the strength, right? It is going to have, you cannot use it because of the load, and high-rise building will have heavy load, heavy weight of structure is going to be coming on the formworks, so it will be avoided. It will be hardly used for that one. You saw on the what, the slab, they use only for slab. All the scaffoldings and the bottom beam and column will be made out of metals. Wherever the load is relatively less, you can use timber, and duration of construction also less, you can use it, like bungalow type, a residential building, 2 stories, a small workshop, right? A kind of a workshop industrial building with one floor, 1+1, can use for wooden formworks and scaffolding. If high rise multi-story, must go for steel due to all these defects and problems. Instead of attending these problems, you can spend a little more money for getting your steel, which is strong enough, right? With some disadvantages still there, that can be encountered compared to fixing of these problems due to timber for high-rise buildings or multi-story buildings. Okay. Any question? Before I continue, I want to do this part like because it's a icebreaker. Like last time, the quizzes, your results. I saw the results. Like in the beginning, I don't remember now, but some of the questions, the question 5, are not correctly answered. Let me give you the answers now. All are there, right? Okay, number 1 question, what are the two, I didn't share you. Let me share the slide. This one. Eh, You can see? Yeah, you can see. What are the two examples of hammer types used in defoundation? It was asked all these things, right? The right answer is the green one, gravity and sonic power driven hammers. Not these types used in defoundations. Please make note of this. Gravity hammer and sonic power driven hammers. And then deep foundation is dash from shallow foundation. Your answer may be it is differentiated from or distinguished from shallow foundation. According to the site condition, you may have to change it. And then or made a foundation, deep foundation can be made out of multiple shallow foundation, one after another. You can make it, or made out of bottommost maybe a slab and then a small slab like shallow foundation. On top you can construct deep foundation. Chances of and these two answers are the alternatives. Can be made out of or made from shallow foundation. Are you following? And then what is the use of driven pile? The question, is it right? Your voice. What is the use of driven pile? One moment, sir. Let me give the answers. It is there. Okay. Where is this? Here. In board piles, reinforced concrete is used for dash. So the answer may be reinforced concrete. You go for reinforcement steel with concrete whenever there is a high-rise building, right? You cannot just go for a concrete. Chances of brittle, chance of cracking faster. So you must go for supporting high-rise building by means of reinforced concrete types of piles, or otherwise adjusting size of the building. Whenever there is a need for adjusting size, because if you have precast piles, you cannot cut according to the size and the requirement at the site. It's good if you make it at the site using concrete. That's why we go for reinforced concrete. It's easy to adjust according to the size and the height of the pile required. And then this question, most of you get wrong. Don't remember this? What is the concept diagram showing here? This diagram, I think you have a nice diagram in here, like this. Can you see? Yeah. See these two types of drawings. I don't know whether I can use it. Okay. I cannot use the my mouse. Okay. The first diagram is showing what? Can you answer me? What is the first diagram? Quickly. What is the first diagram? What is the first diagram saying? Susie Ann is there? No. Zian. What is the first diagram? Can be wrong, don't worry. You can switch right. What is the first diagram?
I'm bearing pause.
Very good. Very good answer. See, it is the first one. Second one, anybody else? I will explain next. Maybe Mok Zi Zeng. Mok Xian Seng. What is the second diagram saying? She answered very correctly the first one. Second pile, what is the second pile? Can you all see the pile? You can see, right? What is the second diagram quickly? Anybody?
Friction pile.
Very good, friction pile. See, I use this one. Why is running? This is the pile, right? It can be driven or dropped, right? Driven, dropped, or drilled. There are different types. Whether you use a gravity method, whether you use the diesel engine, whether you use any of the machines to drive in. right? In all, how the distribution of load, this diagram is showing how the load is distributed. Number one, is this causing trouble to me? Okay, say, oh, go here. This is the friction, right? This pile is distributing the load of the structure to the ground by friction. What do you mean by friction? Resistance to the deformation, resistance to the movement. So what does it do? This pile distribute the load to the side, distribute the load to the ground by means of its friction between this pile and the soil. Okay, it resists the moment. The pile material resists the moment by offering a frictional force between this soil surface and to the pile. That's how it distribute the load to the ground. And in this case, here there is no end arrow. In this case, there is a imagine there is a rock surface, and here is a rock surface. So the end itself, if the pile is sitting on a rock surface, hot surface, the ends will transfer the load to the rock surface. The rock surface will act as a bearing or supporting the load that is coming from the superstructure. So the pile, how the pile distribute the load of the superstructure? By distributing by resistance offered by this rock material at the bottom. Okay, that's why N is bearing the end is bearing the or distribute the pile is distributing the load to the rock surface. By means of that, the structure is supported here only by friction of the pile and to the material surrounding or ground or the earth material surrounding the pile. So this is by friction, this is by end bearing. The load distribution method la. Write two advantages and disadvantages of deep foundation. This is very theoretical one. You have number of things like about 10 or 20 I listed in the slides. You can generally say about what are the advantages, right? You can take up many heavy loads. It will be long lasting, right? If you go for deep foundation, it will be long lasting. Take up heavy loads. If the soil is poor, you can advise for deep foundation. Disadvantages: expensive, right? Expensive, may be expensive. Then workmanship will be tough, right? Tough. And then what else? What else? The disadvantages should be relatively less than the advantages, because mostly, right, most likely all types of high-rise building, they go for deep foundation, right? And wherever the soil is poor, you go for deep foundation. Wherever the condition of the site, the condition of site is located in a swampy land, or the climate is keep changing, you really go for deep foundation. So disadvantages will maybe like very expensive, and then handling, right, difficult to handle, difficult to like wherever it is possible, you can construct with the shallow foundation, you can advise for shallow foundation. Wherever it is not possible, then you must go for deep foundation. Okay, affordable, handleable, and then what else? Material wise it is differing. Again, it differs by the disadvantages. It's following the material. You can classify based on the material of the foundation. And then what else? Yeah, if you construct at the site, again, if it is a steel, it's difficult to adjust to the size of the foundation. Whatever the pipe they are supplying, you need to construct it. Or care should be taken in supply before supplying. What is the depth of foundation you're going for? Accordingly, you order for the piles, number of piles, and the size of the piles. So these are the one by one you can say the disadvantages with respect to shallow foundation. But in common, all the high-rise buildings, poor soil structures and the site condition is poor, then you have to go for deep foundation. Okay, anything else? That's all right. So these are the answers for review. Now I need your attention. We're just on 5 more minutes. Can you all go to the Padlet? I request you to. There is a link I posted, right? Please go to the Padlet. Can you see the link there? I share the window now. I have posted the Padlet session for you. All of you click on the link and the link. Can you click on the link? This link. Can you all click on the link? Did you do that? You can see the Padlet, right?
Yes, miss.
Can you start typing your questions? Whatever the questions you have, number one. We are going to have just 4 minute session in this. You don't have to mention the name. You can type in what are the questions. You are not technical questions, all the logistical things, or how the classes are organized, and you have any questions on the notes, collection of tests, and the materials, classes, online, offline classes, assessment. If you have any question, you can start type quickly. I will answer one by one.
Excuse me, miss.
Mm.
Can you repeat that? Sorry, my call disconnected.
One moment, I put the voice full. Okay. I have opened a Padlet now. I think all of you can see, right? Well, let me share first so that everyone can see. All of you go to the link first, the one I mentioned to you just now. Did you go to the link? Why you cannot see the Padlet? One moment. Padlet, sheet, desktop, window. One moment. Can you hear me? Hi, can you hear me?
Yes, miss.
All of you can see the Padlet. You can
Yeah.
type in all your questions related to teaching materials, assessment, venue, or final exam, anything related to this module. This module you can type in here. I will answer now. If anything I cannot answer, I will post it later in the same Padlet. Anytime you can access and have the answer for you. Okay, this is a thing to have in touch with between the lecturer and students, so that there is no gap, right? You should not come at the end of the day. That's my main issue. Any problem you should suit it on the same day or immediately. Immigration problem, what passport problem, renewal problem, please go to AA. Module, all things related to this module, please type in here. Maybe I stop recording. One moment.